Hi, my name is Michael Vanter. I'm a member of the Maxine project here at Sun Labs, where we're raising the bar in virtual machine technology research. We have several strategies. One of them is to implement the virtual machine entirely in Java with a meta-circular design, which has a number of interesting advantages. One of our strategies for virtual machine research is to open up to a wider community in open source and make it possible for more people to do research in the area of virtual machines. One of the things we've done to make that possible is we have built a special tool for doing virtual machine work. The inspector, as we call it, the Maxine inspector, allows us to examine the internal state of the running virtual machine and manipulate it in a variety of ways. This is the inspector running, showing the state of a running virtual machine. It's paused at the moment, and let's look at some of the kinds of information you can see in the Maxine inspector. In the upper left, you'll see a list of the threads that are currently active, including the native thread that we started with, and all of the threads. A number of other views are coordinated. So for example, if we select a different thread, we will see state associated with that thread. Here we have the entire contents of the registers of the hardware. Over here we have the memory area dedicated to thread local storage with a complete rundown of what's in it. Over here we have the stack for this particular thread, the stack frames, and when I select one of those, we'll actually see the variables on the stack frame. We also can track the allocation and management of memory, which is an important area of virtual machine research. You'll see here at the top of the screen a summary of the memory regions that have currently been allocated, what part of the system allocated them, and how full they are at the moment. We also have debugging functionality in the inspector, and so you'll notice a list of currently set breakpoints where we're resting at the moment, and the ability to step through code. Our code display shows the compiled machine code on the left, because the Maxine Virtual Machine runs entirely in compiled code. To the right of it, you'll see actually the Java bytecodes that were used to produce that code. We can actually set breakpoints in both bytecode and machine code locations, and we can single step through, and we can actually watch our execution location in both views. Another important area is the heap browser. We can actually find a pointer that points into the object heap and view it as an object. Recall that with a meta-circular design, everything in the internal representations of the virtual machine is a Java object. Let's look at one right now. Okay, this is an object in the heap. You can see we've given it a unique identifier. We have some header information that explains how the representation is related to other objects, and the class information, and a list of the fields. Any place where we see an object pointer, we can actually go see that. Okay. We can also inspect memory at any particular location. So here is a low-level memory inspector for the same area. We can actually then move up and down and look at any piece of the virtual machine state at lower levels of abstraction or higher levels of abstraction, depending on what sort of debugging we're doing at that time. Another important feature I'd like to show you, one is which currently under development, is the ability to set memory watch points. In other words, the ability to tell the virtual machine to trap when something changes someplace in memory. Now, like many debuggers, we can do that at the low level of raw memory, where we can say, watch this address for any change. A much more interesting technique is supported by the inspector, which I'd like to show you right now. We can bring up an object inspector, and we can look at any particular field and simply bring up a menu and ask that the virtual machine, the inspector, watch this field's memory. At that point, you'll see an indication that there is a memory watch point set at this location. We can configure that one with another button press, and we can say trap on read, trap on write. We can also specify that it will be enabled or disabled during garbage collection. Sometimes we just don't want to know about garbage collection. Other times it's important. We can manage our watch points with another view that summarizes those. I'll bring up that view right now, and you'll see here an entry that describes the information about this watch point. What's important is that it's described not in terms of a low-level memory address. Rather, it's described in terms of the field of an object. What that means in practice is that the inspector can observe when a garbage collector relocates that object and can move the memory watch point along with it. With the Maxine and inspector technology, we imagine that experimentation with virtual machine technology can now be open to a much wider audience. This might include developers themselves who would like to prototype rapidly some new or innovative feature in the virtual machines they're working on. It also might include upper division and lower level graduate students aiming to get some early experience in virtual machine technology, an area that until now has been accessible only to a very, very small number.